Good morning. I have a slight cold, so my voice is not usually as deep and interesting as this. Um, so today we're going to talk about reading other people's code. And this is something that we all have to do a lot of the time. And very often, especially trying to learn a brand new code base is very hard. So first, who am I? My name is Patricia Aas. I am currently a consultant. I've worked on in many different big code bases. The first one I worked on after university was at Opera Software, where I worked on the Opera desktop browser. And then I was a consultant for a couple of years, working mostly in Java. I've been working mostly in C++ most of my career. And then I went to Cisco, where I worked on embedded telepresence systems for 5 years. And then I went back to making a browser again at Vivaldi, where I worked on the Vivaldi browser. So 6 months ago, I started working for myself at my company, which is called TurtleSec. So a little bit about what we're going to go through today. Just a little introduction, so you got somebody else's code. Then some tips to get started. Then we're going to go through 10 techniques on things you can do to navigate the code base. And then we're going to look at the other end of this. How are you going to, if this is your code base, how do you need to think to receive a new contributor into your project? So you got somebody else's code. And very often people are very skeptical to code that is not their own code because, we are used to the way that we program, and we have a tendency to be more skeptical to other people. So the most important thing when you're approaching somebody else's code is to think that this is not a code review. In this case, what you are going for is trying to maybe add a feature, understand how it works, maybe become a contributor in this project, something like that. Because one of the things that's important to realize is that if you are looking at the code with a critical eye, you won't learn. Because if you come with it to learn, you will learn, but if you approach to criticize, you will criticize. And it's a very strange thing, and you will see that in code reviews as well. That code reviews have a tendency to split on the people who know the area really well. They have a tendency to look at functionality, whereas people who don't know the area very well have a tendency to look at syntax or style. So this is a quote from a very famous old book called How to Win Friends and Influence People by Dale Carnegie. And it says, instead of condemning people, let's try to understand them. Let's try to figure out why they do what they do. That's a lot more profitable and intriguing than criticism. And it breeds sympathy, tolerance, and kindness. And I say this way up front because we have a tendency when we approach a new code base, and you often see this with new employees that come into your company, is that they'll start off really critical. And the thing is, if you want to contribute to a new project, you want these people, this team, the people who maintain this project, you want them to like you. So approaching it with a curious eye, with a learning attitude, is much more conducive to making people like you than coming in and criticizing them. But first of all, I think it's important to think about what it means to approach code that is not your own. To me, in my mental model, code is a serialized version of a mental machine. When I program, I have an idea on how I want things to work. When this thing happens, this thing here should happen, and then it kind of flows in this mental machine. I have a mental model. It's very visual to me. But to program, I have to serialize this into code. It has to become classes and functions and interfaces and layers. And this serialization process is fine when it's my own code. I can also, when I read my own code, I can see the machine and I can make adjustments. And if I get a patch on my own code, it's much easier for me to map that to my own mental model and to say, oh yeah, but that's not going to work because of this thing over here. But when we approach somebody else's code, we don't have that mental machine. We don't have that model on how it's supposed to work. And this is interesting because we have a tendency then to think that there's something wrong with the code because we don't understand it. Because we don't get that feeling we usually get when we're looking at our own code. Now it's just files on disk, possibly hundreds or thousands of files on disk. And it just feels like, okay, so yeah, I cloned the project. What do I do now? And also the fact that running code is not linear. If you run the code, it's going to be jumping around from different files. It's going to be like, okay, so you start up here, maybe in Maine, if that's your language, and then you hop around from different classes through different layers of abstraction. It's not linear. It's not like you got one file, you can start at the top and read to the bottom. Also, starting at the top and reading to the bottom of a code base doesn't scale. You could try to read code when it's a small project. A couple of files, you can try to read it all. But the moment you end up in bigger code bases, and I've seen some really big code bases, this doesn't work. Vivaldi, if you include the Chromium code base, has 600,000 files. There is no way you can read it all. Even if that was your sole goal for your entire life, you sit down and I'm going to read it from start to finish. And also, the whole project would change while you were reading it, right? So we need techniques that scale on bigger projects and bigger code bases. Okay, so before you start, there's certain things that you should do to set yourself up to be more productive in the other techniques. But not only getting started, or not only like before you start, but also getting started, because very often it feels very intimidating. Approaching a new code base and you don't really know how to start, and it becomes like a thing, and then you don't know what to do, and then you go take a coffee. So these things are things that you know how to do. So first of all, get the code on your machine. Some people try to do this like online, like, the code is there, I can just browse it on GitHub or whatever. It's really impossible to really deep dive in a code base if you don't have it locally. Because when you have it locally, you can do stuff like you can put it into source control. If it wasn't in source control already, then you can, but the thing that you can have now is you can make changes and you can easily roll them back. Because what you will often do is you'll add some stuff places like, do I get here? What happens if this one is different? And you will make changes, but then, you probably break something or it's not interesting anymore, and then a hard reset is possible. Then you probably want to put it into the smartest IDE you can afford, because then you can leverage the IDE for all it's worth. And then you want to figure out how to build it, because if you can build it, you can run it, which is a feature. Because if you can run it and you have it in a debugger, there's a lot of things that are now available to you, like setting breakpoints and stepping through things and inspecting runtime state. And also, I would actually say try to figure out how to run the tests. Because if you can run the tests and maybe add tests, then that is a way to figure out how is this application exercised? What are the different ways that it is exercised? And then maybe set up something that addresses the use case that you're looking at. Okay, so why would you do this? Well, usually you would have like a good reason. Like, let's say that you had an exception in your project, or something ended up in your logs and you didn't understand it. You Googled it and you didn't have any hits on Stack Overflow. And suddenly now you're like, okay, so I have to check out this framework that we depend on, apparently, and try to figure out what is going on. But sometimes you just want to contribute to a project to learn something, maybe. Or you want to make some documentation for this project, which is a really good start in getting people to like you. If your first pull request to a project is refactoring their API or some part of their project, they're probably not going to be very happy. It's not a very good way to get on somebody's good side. But if you come and your first pull request is for documentation, people are usually really happy, and that's a good way to get people to like you. But also you might want to teach others. It might be some dependency that you have in your project that other people in your projects don't really understand either. So if you sit down and you learn it, then you can try to have like an internal presentation, teaching it to others, maybe even go on a conference and hold a talk. But code, if you look at it, like all of the files on disk is basically balls of yarn on the floor. Each thread is basically a thread of execution, but it's all a big mess. And trying to figure out how it is all hooked together is basically, where do I begin? I mean, you could start anywhere, so where do I start? So basically, the whole idea is find an interesting end, and then you pull on it. And an interesting end could be many things. So I will go through how to do that, but the basic process that I'm going to describe is iterative. So you go through things, you establish a vague outline, then you flesh it out by trying different techniques. And I really would recommend taking notes and drawing things. Just because it's complicated, you don't know it, and as you move along, you will learn things that when you read through your notes, you go like, okay, so that's why that was that way. Okay. So the 10 techniques, or finding an interesting end to pull on, are, and I'm going to list them here, and then we're going to go through them one by one. So the first one is grepping. Then where's this button? Following input events. What do the tests do? Refactoring, reading Maine, the graphical layout, runtime investigation, reading a class, and retelling or rubber ducking. Okay, so let's look at grepping first. Grepping is an interesting thing because it is something that we all do, but we don't really like to talk about because it doesn't feel like engineering. It feels sort of like random. You're like, okay, so I don't know how to start, and I have this string in my error log. Okay, so I'm just going to grep for the string in this massive code base and see what happens. And the thing is, it doesn't feel like engineering, but it is a massive part of learning somebody else's code. And it is a very important technique, and you shouldn't be ashamed of it. So you find a string that is interesting to what you want to look at. Now, that could have been in the GUI. It could be something that you see when you do help on a command line tool. Or it could be in the logs, right? Any kind of string that you see that you find interesting, and then you just grep for it, and you figure out where it is in the code base. This technique is used in many of the other techniques as well for finding stuff. But oftentimes it might not be like a literal grep. It could be like find usages or something like that using your IDE. So one place that we can use that is in where is this button? So here you have the text on the button. So if you have a GUI application, you have a button, and then you go like, okay, so where is the code for this button? And then a good idea is to grep for the button text. Hopefully it's not like okay, because that's kind of everywhere. But if you find a button that has a little bit more text on it, it will probably be unique. So grep for the button text, then you find, you will generally find first, you'll find the text in a localization file if you have like a localized application. And then you'll find some kind of constant, then you grep for the constant. This is like a process. And then you find the button definition somewhere. Once you found the button definition, then you try to find the on-click, and it's usually around the button definition someplace. And then you set a breakpoint on this. Now, of course, to be able to set a breakpoint, basically you've done basically almost all of the pre-steps. So you have it in a debugger, so you're able to set a breakpoint on it. And then you click the button. The good thing is that the moment your breakpoint hits, you suddenly have a lot of information. You have the information on the runtime state at the point when you click the button. And there's a lot of things that are in play at that point. The whole UI is up. All of the inheritance hierarchies or the widget hierarchies are up. And you can start inspecting those. You can also look at the stack, and you can figure out, okay, so how are events propagated in this application? Like where do they come from, and who do they pass through? So there's a lot of things that you can do, but also you can also traverse up the widget hierarchy, and this will show you how the UI is structured. The button will be on a view plane, the view plane will be on maybe in a dialog, the dialog will be a child of a window, and that will give you an idea on the actual structure of the UI. And then you have, so that is more like a top-down approach. Then you have a bottom-up approach, which is following input events. Following input events is something that is useful if what you're looking at is a GUI framework. So if you're trying to figure out how your GUI framework works, then this technique is very useful. It's based on two interesting things about GUI frameworks. They have two things they have to do. They have to feed input events from the platform to whatever widget has focus. And they have to, or to any widget that, if you mouse over something to give it a mouse effect, or if you click on something, whatever was clicked on. But the other thing that a GUI framework has to do, it has to produce a frame that can be shown on the screen. And these two things are true for all GUI frameworks. And trying to figure out where that logic is will lead you to the heart of the framework. Because GUI frameworks are massive. So trying to figure out what is the central components to figure out how it works, trying to trace these two things, where is the output frame coming from, and where are the input events going in. That will lead you to the core of a GUI framework, and that's an easy way to try to figure out how it works. Yeah. And that's also where you will probably see any kind of platform integration as well. Okay, so then you go to what do the tests do? And I talked a little bit about that earlier, because the test will generally show you the use cases for this code base. Like what are especially because we're looking at integration/system tests. Unit tests are very useful for many things, and in this case also if you make changes or you're looking at a specific function, but generally you are looking at much bigger things. You're looking at the whole code base, trying to figure out which parts are interesting. And therefore, the integration or the system tests are more useful. Because these exercise the entire application and will show you how it is exercised and what kind of use cases you have. It will show you how to run it, which you might not know how to do. And it will show you the general use cases. But it would also give you an opportunity to copy one test and try to modify it a little bit so it meets the requirements that what you're looking at. Let's say that you are trying to figure out an error, so you're trying to set up a test that can reproduce the error that you're seeing in your own application. And that's a very nice thing to do, because it basically, every time you want to go through it, you can just press the run button instead of having to go through your application and doing all of the things to get to the error. If you can set up a reproducible test case, that's also something that you can submit as a bug report to this framework, right? So you can write tests to examine your assumptions. You can say okay, so I think that if this happens, then this other thing should happen. And then you can run it and you can see if your assumptions are true. And then we come to 5, which is refactoring. Refactoring is probably the most dangerous of all of the techniques, and I kind of got into it earlier. And the reason for that is refactoring is opinionated. There is no reason you would submit a refactoring as a pull request to a project unless you thought that your refactoring was better than what was there already. Submitting a refactoring as a pull request is criticism, because if it was worse or the same as it was before, there would be no reason. So by the very nature of it, a refactoring is criticism and is probably a bad place to start. So using refactoring as a learning technique requires something, because this is psychologically difficult for people to do, because refactoring requires work. So before you start this, don't get attached to it. You have to know this is stuff you're going to throw away. You're not going to submit this pull request. You can do all the refactoring you want. You just have to know that tomorrow or the day after, there will be a git reset hard in my future. this thing is not going to live. And that is something that is kind of hard for people to do because you've invested all of this work into it, and you probably think it's better. But it is a really bad place to start. So think of this as throwaway code, and do it as a learning exercise. Okay, so then we come to reading main. And I say main in quotation marks because it doesn't have to be main. It basically has to be some function that drives execution in the part of the code that you're looking at. And drives execution, I mean, very often we have classes that are basically just objects or just containers for information. And then you have, and you know, we used to talk about model control view. Some people still do. And this will be more like your control type of classes, things that actually have functionality. And here you will try to figure out what are the core functions there. And these I would actually recommend reading. Because what drives execution will generally have important logic. Like if it is an actual main function, it will have oftentimes your main loop if you're in some kind of framework that will expose this to you. And it will have the beginnings of your event handling. So I would suggest reading it top to bottom because it usually holds a lot of important logic and a lot of important objects. Like these are the central classes in this code base that build like the core parts. Also, I would look for common types, like things that are passed around. Or if you're using some kind of a dependency injection framework, then look at what is injected into everything. Because it's like if you have one specific class that is a singleton or something similar to a singleton that is injected to everything, it probably contains really important stuff. So take notes, draw it out, try to figure out how this works. And you don't have to you don't have to finish everything. You can just do something, put it aside later when you learn something else. You pull it back and you're like, okay. So that's the reason it comes in there. And this is a recursive process as well, so you might have to go through a couple of layers because people have a tendency to want to like clean up this main function and make like sub-functions that take care of things. So you might have to go through a couple of layers. Okay, so we talked a little bit about the graphical layouts and where is this button and following input events, but there's a specific part of a layout code which is really important to look at. So this is if you're looking at a GUI application and you want to know how the GUI application itself works. Because we looked at the layout, and that's more of a declarative part of your GUI application. And then the input events is more of your GUI framework. But this is about the application, the GUI application itself. So we're going to look at what I call the main layout. And the main layout is, the best way to describe it is if you look at an application and like Gmail, for example. So the first time you go to Gmail, you've never gone there before, you get this page where we go like, okay, you can sign up. Okay, and then you click, okay, I'm going to sign up, and then you can log in. And then after you logged in, you come to your list of messages, and then you might want to open an email, or you want to compose an email. The things that are important about what I'm saying is, first of all, they are like clear use cases. They're like, you can describe it to a UX designer. It's like, yeah, open email, compose email, log in, those kinds of things. But also what you will see is that the whole window changes. It's a totally different layout of the whole window. This is like very, very different. And you have to transition between one look in the layout and a totally different one. And finding the code where this is done, this changing the entire window contents, that is what I call the main layout. And if you look at that, you will generally find if you have developers that have done a lot of GUI applications, you will find an explicit state machine here, where basically we're in the logging in state. If login is successful, we will go to the logged in state. They will actually have explicit transitions between different states. But most places people haven't really done GUI applications a lot before. So what you will find is a lot of Booleans. It's like, is user logged in? Is composing email? All sorts of things like that, like a whole bunch of Booleans, and then you have lots of if statements, like if user is logged in and is viewing emails and those kinds of things. But if you can find that code, that is a very central part of that is the core part of a GUI application. It's the one that's going to switch between the different layouts, between the different functionalities. And then we come to runtime investigation. Runtime investigation is very popular, especially for people who are used to working on backend. And we'll look a little bit at that. Because if you have something that is mostly synchronous, if you have an application that you're looking at which is mostly synchronous, and this is true for things like command line tools, but it's also true for backend. Because backend is like, yeah, you have many threads, and yeah, you might do a little bit of threading, or a little bit of async, but not that much because you still have to wrap it up because you have to get a response back. So backend developers are used to working in generally mostly synchronous applications. And if you are working in a mostly synchronous application, the debugger is awesome. Because basically you just set a breakpoint wherever you're interested in, and then you just step through the whole thing. It's very great. So if you are used to working backend, you're usually very comfortable using your debugger. However, if you're a front-end developer, you're working in a code base that is generally asynchronous, which basically means you keep on having handlers for things. So when this happens, then this thing should happen, and then you have to send a request to the backend, so that's also asynchronous. And then when that comes back, then you have to do something, but then something might have happened in between, and it's a very different way of coding. So using your debugger for a front-end developer is not as comfortable, and the flow is not as comfortable. And that is something that you kind of have to realize, when, especially if you're a back-end developer and you start to do front-end, that you just don't feel like you get the flow, and that's because it's just harder. So what you often do is you use logging, and then you feel a little bit unprofessional because you're logging a lot. But basically the idea of logging is that you insert logging many places, and then you run the application and you see, and you do your scenario, and you see which logging statements you actually hit, and then you put breakpoints on all of your logging statements. And then when you hit the first one, it's like, and you step through the code there, and then you come to some async stuff, so then you just do continue, and then you will hit your other breakpoint. And in this way, you can kind of do a semi-good debugging of an asynchronous application, which involves just continue, break, continue, break, continue, break. Then you have something that it has hard deadlines. These are very difficult to debug, because if you break, then some kind of deadline will break, and then the whole process will kind of just end, or you will skip a frame, or you will do something. So if you have something that is real time in some kind of way, then oftentimes what you will do is you will do printf debugging. Especially if you have, like, let's say that you have something that fails 1 out of 1,000 times. You can't step through it and find the error because it only fails 1 out of 1,000 times. So what you want to do is you want to log a lot, and then you want to look at that log and see what is different the times it fails. And then you have the idea of using a profiler. And a profile can be very interesting from many different ways, like especially if you have a scenario where sometimes it's really slow. This can show you what is really slow, which part of it to look at. Because very often, especially with optimizations, people have a tendency to imagine. Like, I think probably this part is the part that is slow. And of course, everybody says you should measure. But the profiler can also give you more understanding on how things actually work. You might not realize that certain parts take a long time, and that might be useful information. So we looked a little bit at the different architectures already, but I kind of want to split it up. So if you were in an event-driven application, and this is generally something that is asynchronous because of some kind of constraint. So in a GUI application is highly asynchronous because you don't want to block the UI. You don't want to, like, if you click a button, everything freezes until something happens. And because you don't want to block the UI, you constantly have to dispatch something, and when it's finished, it has to come back, and some kind of handler will have to be handling it. But this is true for many other different applications as well, as long as you have hard deadlines. So any kind of trading system or anything like that, anything that has hard deadlines will have an event-driven architecture. But if you are more of a request handling architecture, so this is more of a back-end type of thing, you will generally spawn one thread per request. So just you'll have a thread pool. You'll spawn a thread for that request, and then you go back to listening again. And if you have a command line tool that is even more synchronous and less problematic than the others, because you got an input and you have to produce an output. So and then you're finished. So you can use the debugger to examine your runtime state and your stacks. And we looked at that a little bit in the finding the button. You can read the logs to see the flow. This is how the control flow is. When I'm here and this happens, then I end up in this other file over here. And then you can use the tests to drive the flow. So you can construct the flow that you want to test, the one that you want to examine. You can add lots of logging. You probably will. This is where having it in source control is really good. Adding tests and assertions. But I would also say, if you really want to learn a code base, try to add a feature. You don't have to actually push it. It doesn't have to be a real feature. But trying to add a feature involves a different kind of understanding. Because very often you will think you understand and you go like, okay, yeah, that's fine, and blah, blah, blah. But the moment you have to do it, suddenly a lot of problems occur and you realize all of the places that you didn't understand. So that brings us now to reading a class. A lot of the other techniques were about trying to narrow down the focus. Let's say that you have 600,000 files. Which 10 files are interesting? Because you have to narrow down to something that you can actually process. But now you're coming down to smaller and smaller code. And in reading a class, there are certain techniques that are useful. First, look at what kind of interfaces does it implement? But even more than that, I would probably say who uses it and how. So try to find usages and look at the calling code, the client code. The people who are calling this class, what do they use it for? Which functions do they call? Because you could look at just the public functions, and that would be fine. But very often what is public is sort of random. And what you want to do is, what is really the interface? What do the clients of this class actually look at? What do they use and how do they use it? And often the public functions contain a lot of other stuff, like getters, for example. So the moment you get to the point where you figure out this is like the one or two functions of this class that are like super important, then you treat them like mains. These are the functions that are driving the execution of this class. The class generally has lots of properties and things and state that it holds, but these functions are the ones that show how it uses the state to accomplish something. And then that leads us to the last one, which is retelling or rubber ducking. So rubber ducking is something that many people might have heard of. I'm not a big fan of the word because it is, or the phrase, because I don't think it really works. Because the idea in rubber ducking is basically that you have a literal rubber duck on your desk, and then you explain stuff to a rubber duck. Now this has two problems. First of all, people will think you're crazy. And it won't work in like an open plan office. It's like everybody's like acting like normal people, and there you are talking to the duck. And the other thing is, it's very hard to be motivated to actually explain anything to a rubber duck. It just feels dumb, and you probably won't do it. So I would rather go for retelling. And this is something that you all probably do. And that is explain it to somebody. And I think probably all of you have been in a situation where you've been debugging something and you just can't figure it out, and you're just totally lost and you don't know what to do, and then you go walk over to a colleague and you go like, okay, so I don't get it, I don't understand it. And they're like, okay, so what's going on? And they go, okay, so first of all, I do this thing and then this other thing, and then you kind of stop. And they're like, never mind. I know exactly what it is. And this process you can also do if you're home alone, like that you don't have a colleague to explain it to. You can write a blog post. It could be fictional, you don't have to publish it, but you have to have the feeling that it's real. Very often, I talk to many people who say that like 90% of their Stack Overflow questions, they just throw them away. Because by the time you've written the whole question and you explained all of the stuff and everything, then you know exactly what's wrong and you don't have to post it. Some people actually have a tendency to say, okay, I will post it anyway, and then just say that, you know, this is how I found it out. But having the motivation of trying to make somebody else understand means you have to put in some effort. You can also try to write documentation. One of the things that I've seen a couple of times actually is people who are maintaining a project and they're going to pass it over to somebody else. And so they're like, okay, so I probably should write some documentation because I probably haven't. I was like, okay, so I'm going to sit down, I'm going to write a README, I'm going to show, so it's much easier for the next person to, you know, take over. But while they're writing the README, and then it turns out the README was like this long, and it involved lots of manual steps and everything, and then you go like, I should probably automate some of this. By the time they're done with the README, they've done a massive refactoring in the README, it's this short. But just the fact that you have to express it often realizes the weaknesses, and both in your understanding, but maybe in the code as well. And then you can make an internal presentation. If you feel that you've spent a lot of time on this and you felt like, okay, now I've spent a week trying to understand this framework just to fix this one bug, then maybe you can repurpose that work to make an internal presentation. And other people might actually get, you know, a little bit smarter from this. And yeah, ducks aren't very motivating. One thing that is important to understand, that all of these 10 steps, they are, like I said in the beginning, it's an iterative process, right? It's about doing these things. Establish a vague outline, then you do another thing in the list, then you flesh it out, and you take your notes, you draw it out, and as you go along, you will build up this understanding. And that brings us to the other side. What if it's your project? And now this person is coming in. And you want to be a welcoming project. You want to be successful. You want the team to be great. What can you do to set your team up for success? So this is going to build on some research around what team excellence is about. Because what is the predictor of team excellence? And this was a question that Google asked themselves. And they made something that's called Project Aristotle. How many people have heard of Project Aristotle before? Yeah. And what they said was what they found out in the end was that the predictor of team excellence is psychological safety. This was surprising to them. This is not what they thought. They thought that what you would see is an aggregate of all of the excellent individuals would make a more excellent whole. But what they saw was that the individual excellence was not a predictor for team excellence. And this was a big problem in the research for this project because they didn't understand. They got results, but they didn't understand it. And then they came over some research that a woman had done, and we'll look at that, which explained the results they were getting. And that is Amy Edmondson. She wrote something called Psychological Safety and Learning Behavior in Work. I'll read the quote. The term is meant, and this is psychological safety, the term is meant to suggest neither a careless sense of permissiveness nor an unrelenting positive effect, but rather a sense of confidence that the team will not embarrass, reject, or punish someone for speaking up. This confidence stems from mutual respect and trust among team members. Now, her research was not in IT. It was in teams in general. And it has to do with if you want to contribute everything that you have to feel that if you say something, then people won't jump on you. Because if you are in a team where the tone is really harsh, then you will think twice before opening your mouth and saying something. And the problem is then we end up with people not speaking their mind and not contributing everything that they have. And I spoke to someone recently who had this specific problem in their team. And they said, you know what, when this other person's pull requests come in, I don't say anything. Even though it's bad or there's something wrong, I don't say anything because it always ends up blowing up in my face. And I'm like, okay, so what happens when you do something? Oh, this person is all over everything I do. And then you end up with a weird thing where somebody will actually get all of their bad code into the code base because nobody wants to take that fight. But what is psychological safety really? And I will try to explain that in terms like that you will know. And this is Amy Edmondson. She has this matrix trying to explain the different types of levels of psychological safety. So first of all, you have the idea of psychological safety going up, motivation and accountability going to the right. And the first one is if you're low on motivation and accountability and you don't feel psychologically safe, you come into apathy. Apathy it's meaningless. There's no point. There's no point in doing anything. Nothing really matters. Nobody cares what I say. It's, yeah, I'll do stuff. A lot of people end up here if they're bullied in the workplace. You feel like there's no point because nobody listens to you. Nothing you do really matters because people will throw it away or disregard everything you do. If you are in a team where you might still not be very motivated, but you feel psychologically safe, you end up in comfort. Comfort is the thing that most employers are really afraid of. That, you're just going to be like, it's nice to go to work, and I'll drink some coffee, and, you won't really do anything, because it's like, who cares about this thing that we're making? But, I have nice colleagues, and I'll just be here. You have studies where people say, like, is your job meaningless? And, you have 15% that say yes. Okay, they are in the comfort or in apathy. Okay, so they're basically going like, probably nobody needs to do this job, but, I'll show up for the coffee and the money, right? The thing is, in tech, this is not very common. Most people who work in tech are highly motivated, no matter what they do. It's great. It's like you'll put somebody to do any kind of a mundane like programming task, and they will be highly motivated, not necessarily because of the product, but because of the process. They will feel it's important to get it right. It's important to have like a good style and the quality and like all sorts of attributes about the thing that they care about. So people in tech are generally highly motivated. But what happens if you're highly motivated, but you don't feel psychologically safe? Then you end up in anxiety. And this is where people burn out. This is where people are working and working and working and trying and trying and trying and never really feeling like it matters or they can get it to work or they ever get rewarded for what they do. People get really anxious and people can burn out. So all of these are kind of bad, right? So what you want is like the upper right corner. So in the upper right corner, you find learning. If you are in a psychologically safe team where people listen to you, they hear what you're saying, it doesn't mean they have to agree with you. Then it's not like a nodding thing where like whatever you say is great. But you know that if you say it, everything's still fine. And you know that you can say something and everything is still fine. You're still a team, you still feel good. And I think most of us have had that kind of team, at least at some point in our career. something that we couldn't maybe put our finger on why it was good, but it kind of just gelled. And you're highly motivated, but you feel like you matter. You feel like you matter to your team, and you feel like you contribute. So the idea here is generally people in tech are highly motivated. You don't really have to work on making them feel highly motivated. What you need to work on is making them feel psychologically safe. And that means we have to get into a learning mode. Getting into a learning mode is when you're taking in new contributors, try to learn from them. They're probably bringing things to your project that you didn't have already. And this goes especially if you're bringing in people who are minorities in tech in some kind of way. They have experiences, and that might bring new stuff to your project that you didn't know before. Maybe you'll get in somebody who is blind, and they'll give you lots of insight in how accessible your application is. Maybe you will get in someone who is non-binary or transgender, and then we'll go and ask questions. If they feel safe enough, they'll ask questions like, do we really have to ask about gender here? Does that really matter? Can we take that away? Because that might make people feel uncomfortable. Or people who are colorblind, which the thing is, a lot of people are colorblind, but very few people talk about it in their teams. You know, I was in a team once where we were looking at the application. I'm going like, okay, so but the colors here, I don't know. Like, how will this work on somebody who's colorblind? And we're in a team of 4 people. Like, I'm 1 woman, 3 guys. Turns out all 3 guys were colorblind. And none of them had said anything. Turns out parts of the application was absolutely impossible to read because the text in the background basically blended together, but nobody said anything because they were like, it's just me. It's like colorblindness is super, super normal. Okay. We talk about not taking stuff personally. And that is something that yeah, but I'm going to critique you. Yeah, but you shouldn't take it personally. But if you really are invested in what you make, it should be personal. Because you should take pride in your work. You should have, like, if you are feeling safe in you are highly motivated, you are trying to do good work. And that is going to be personal. And trying to pretend like it's not personal is not helping. Because we're basically just building toxic environments where people are just mean to each other. And decreases psychological safety. So we kind of have to go in, people are going to take it personally. But that's something that you can take into account. Maybe you can formulate your criticism in a different way, going like, okay, so you know what, this stuff over here, I love it. And this thing here got so much better in what you did. I'm wondering about this thing over here. Maybe we can do it differently. How you phrase things can make a big difference in how it is felt on the receiving end. And style. We have a tendency to be crazy about style. For some reason, it's like you'll get a pull request and it will do all sorts of functional changes, but somebody will absolutely go crazy about a missing space or the curly brackets are in the wrong place. We need to get over the whole style thing. Like some projects, they just can't get over the style thing, so they just automate it away because, then you don't have to think about it. But I think probably style is a good way to practice on not getting worked up over stupid stuff. It's just, it doesn't matter. It's non-functional. Just breathe in. You can deal. It's hard. I know, it's hard. But I think it's a good practice. And most of all, to learn to appreciate other people's code. Because it isn't bad just because it's not yours. It might even be better than yours. You might actually learn something and become a better programmer for it. But it is different to read somebody else's code because you don't have the mental machine. So you now have to build the mental machine out of somebody else's code before you can really understand it like you would your own. And that is my talk. Thank you. So, do you have any questions?
Just regarding the last style point, do you think it helps general readability of other people's code bases if it's more uniform than everybody sort of having their own?
People think so, but in my experience it's not true. Because, and that is the reason why it's, people think so, because they look at the code that's not theirs, and they don't understand it, and then they see that the formatting and everything is different, and they think that's the reason why they don't understand it. But the thing is, the reason why you don't understand it is because you don't have the mental model. It is alien, not because of the formatting, but it's alien because you don't understand it. And I think that is also one of the reasons why code reviews are very hard. Because doing a code review, you get a diff. You get a, sorry. You get a diff, and maybe of some code that you don't know. So you're getting basically an excerpt of code that is representing a mental model you don't know. I mean, you seriously, it's really, really difficult to do code reviews of code you don't know well. And if you do, then you generally end up with style, which is generally useless. But the only one good thing that I've seen of doing that kind of code review is language. So let's say that you have a deep understanding of doing something the Pythonic way, for example. Then you can give good feedback in like, okay, but this you could do in a more elegant way, like this way. But it still doesn't give any feedback on the functionality that you're looking at, right? But at least it is something that is a teaching thing instead of just whipping a dead horse. It's like, yeah. And very often we feel like we have to say something. Like somebody was like, oh, could you review this code? And you're like, okay, I have to critique it some way. So then I'm going to comment on the style. Yeah?
It happens to me because I need to review something that I'm much less experienced, down for people much more experienced.
Mm-hmm.
I used that opportunity to ask loads of questions in the review. Why you did that? I don't understand it. Explain it to me.
Yes.
And that's a learning exercise anyway, because in many cases I cannot provide any input.
Yes. And very often you will have something that looks really weird, and you're like, okay, why do you do that? And then they explain it and go like, oh, okay, because there was some constraint that you didn't know about, which made this necessary in some way. Yeah. Any more questions? Okay, thank you.